In this video 4 we're going to look at entity relationship diagrams, how to design a database basically. I'm going to give you some simple examples, how to join tables using primary key and foreign key joins. We're going to talk about referential integrity and normalizing a database, and we're going to give you a 3-table example, and then talk about database management systems. An entity relationship diagram is a diagram of a database which contains tables. And the idea is you design your database to be as logical as possible in terms of where you store the data, what columns you put in which tables, and how you relate the tables together. So this is very important in database design. In this example I'm going to show you one cat which is looking rather grumpy because it's got fleas on it, and the idea is you have a diagram like this for this relationship. You've got one cat and many fleas, so it's a one-to-many relationship. This diagram we can read from left to right. Each cat in this database can have 0, 1 or more fleas, and we can read it from right to left. Each flea lives on one and one only cat, and being able to read an ERD from left to right and right to left on each of the joins between the tables is quite an important skill. It'll work quite happily with a one-to-many relationship in a database ERD. You can't have a many-to-many relationship, but it does work with one-to-many. If you look here, we've got cat 17 and each flea has a flea ID. The flea ID would be the primary key of the flea table, and the cat ID would be the primary key of the cat table. So looking at how the data would look in the tables, the cat ID here is the primary key of the cat table, and we have the flea ID, which is the primary key of the flea table, and we put in a foreign key, which is for each flea we've said which cat it is, and we haven't put any information in apart from just the ID number of the cat, and that saves space in the database and is a good way of joining tables. So at this point Frida's just joined us. Frida is cat 18, so cat 18's been inserted into the cat table, but Frida has no fleas because all the fleas are for cat 17, which is Tom, the grumpy cat on the left. So if we look now, a flea has now jumped from Tom to Frida, so flea 43, here we go, has now changed its cat ID and now has a cat ID of 18, and that showed its transferred cat. And again, the logic of the database diagram fits. Each cat can have one or more fleas, each flea lives on one and one only cat. So it shows logically an implementation of a one-to-many relationship. So I've got this in MySQL Workbench, and if you look here, we drop the fleas table if it exists, drop the cats table if it exists, then we recreate cats here. Cat ID is the primary key. We've got cat name, which is a not null, gender, varchar, and here we insert the two cats into the cats table, cat 17, cat 18, and here we create the fleas table, more of that later. We insert all the fleas in, and this update statement makes one of the fleas jump cat. So where flea 43 was on cat 17 in the insert statement, the same flea has now changed to cat 18. And this select statement pulls data out of both tables. So if you look at it, it's pulling cat name, flea ID, favourite food from cats, comma, fleas. These are the table names in the from part. Data's coming out of both tables. Cat name is from the cats table, flea ID and favourite food are from the flea table. And this where clause does the joining between the tables. It uses the primary key, foreign key columns, and that specifies the join and makes sure that the data comes out correctly from both tables. So it's where the cats table primary key is equal to the fleas table cat ID foreign key, just like this. And we're expecting the data to look like this. And on my version I've put an order by so that it puts flea ID smallest first. If we run this query, there we go, and you can see it's pulled data from both tables. So select star from cats gives us that, the cats table, and select star from fleas gives us the flea table, and select cat name flea ID from cats fleas where cats cat ID equals fleas cat ID gives us that. So now we're going to mention referential integrity, which is a form of validation in a database. This really makes the foreign key primary key relationship a strong relationship because it enforces it in a very strict way. If you look how I've created the fleas table, I've got a foreign key constraint in there. Now you don't have to put that line in. If you miss out this final comma and miss out all of the stuff I've got highlighted, you can still join the tables and pull data out of both tables. That will still work. But making a foreign key constraint, you are saying here cat ID in the fleas table references the cat ID from the cats table, and this is very, very powerful because it means that you can't create a flea which is on a cat where the cat doesn't exist. And if you try and make the flea jump off onto a different cat, it has to jump off onto a cat which actually does exist in the cats table. The easiest way to show you this working is to demonstrate it. Insert into fleas, values, let's insert flea 999, favourite food, I can't imagine what that would be, and let's try and insert that onto a cat that doesn't exist. Cat 30 doesn't exist because we've only got two cats, cat 17 and cat 18, and let's see what happens. And it says it cannot add a child row, a foreign key constraint fails, and it tries to say what the problem is. It's basically saying you can't add that flea because you can only add a flea into the fleas table if its cat ID exists in the cat table. Let's try and update flea 204. So what I'm trying to do here is change flea 204 to jump onto a cat 30, and again you've got the same sort of thing. It won't allow it because it's validated the fact that cat 30 doesn't exist, so you can't make a flea jump. That's happened because we created this foreign key constraint here, and like I say, if you leave it out you can still join the tables and it'll still work, but if you put it in, it makes the database more strict. It's an extra layer of validation going on. So I want to move on to look at a 3-table database now. We're going to make a database for ePraise points, which are commendations for students awarded by teachers. So these stars, we're going to actually try and make it so the database holds data on which teachers have given which students which ePraise points. And this is a 3-table solution. Now we've been talking about entity relationship diagrams and why they're important. And we've used the idea of cats and fleas to show a one-to-many relationship. Each cat can have one or more fleas, etc. Here we've got a more complicated data model. So if you've got lots of students and lots of ePraise points, it's a many-to-many relationship. It's just overcomplicated. Now we cannot allow a database to model a many-to-many relationship. It'll just be a logical, complete disaster. Too complicated and inefficient. So databases don't do many-to-many relationships. Also, students and teachers, lots of students, lots of teachers, you can't have a many-to-many relationship between them. That wouldn't work either. So the solution is to make the ePraise points table a joining table to join the students and teachers. And if you do it this way round, and you can read the diagram correctly, again you should be able to read each join both ways. So let's try this. Each student can have 0, 1 or more ePraise points. Each ePraise point is for one and one only student, and that makes sense to me. On this side of the diagram, each teacher can award one or more ePraise points. Each ePraise point has been awarded by one and one only teacher, and if you implement that, that's a successful ERD which works. And this is part of database normalization. We make sure when we normalize a database that all tables only contain columns which are appropriate. In other words, each thing in a table relates to its primary key and nothing else. And if you've done that, you've made sure that the table is normalized, it's logical. And in a database, we can't have any many-to-many relationships. So it's all got to be one-to-many relationships. That's what normally happens. If you've got a one-to-one, it means the data probably should be part of the same table, and you don't need to have two tables in a one-to-one relationship. Just put it all in one table. And we're going to use primary key, foreign key joins again. So the student's student ID is going to relate to a foreign key student ID in the ePraise table, and the same on the other side. We're going to have teacher ID in the teachers table is going to be the primary key which relates to a foreign key teacher ID in the ePraise points column. So here you can see I've created a database ePraise, and I'm going to use that database, and I've created a table for teachers just with a teacher ID, which is the primary key, and teacher name. It's got a not null constraint in there. I've inserted 3 teachers, I've created a students table. Student ID is its primary key, forename and surname not null, and I've inserted lots of students. Then I've created a joining table, ePraise points, that has an ePraise point ID as its primary key, and these are the two foreign keys. I haven't bothered using referential integrity, so there's no foreign key put in here formally, but these are going to be used as foreign key columns. They are not null to make sure you have to have a student and teacher ID in there, and what for is going to be the reason the ePraise point gets awarded. And then I'm going to insert all these ePraise points. As you can see, the student is a number from 1 to 10 by the look of it, and the teachers are 1000, 1002 and 1001 are their foreign key values for each teacher. And then we really want to find out which student got awarded what ePraise point, what was it for, and what was the teacher. So we want something useful coming out. So here we've got select, and it selects data. This is in the form of table name dot column name, students.student ID, students.forename, students.surname, teachers.teacher name, ePraise points, what for, from all three tables, teachers, students, ePraise points. And then that won't work unless you have the correct joining clauses in the where statement. So where this is the join between the teachers table and the ePraise table, this one here, and this does the other join between students and ePraise. So this does this bit here. So it's using primary key, foreign key columns to actually do the joins. And I've ordered it by student ID, and it's worked, and here they all are. So it's showing which student has been awarded which ePraise point, and pulls data out of all three tables. Now here we're counting up ePraise points as ePraise points so far, so we've got totals going on. So again, if I execute all, and it's totaled up all the ePraise points for each student. So that's revising the use of group by. So we're going to summarise a database management system, DBMS. The idea of a database management system is you have a SQL database which normally sits behind a front end. Now the front end could be built in Visual Basic as Windows Forms or another higher level program language. The SQL database sits behind that to serve up the data. But most modern databases work like this. You have the front end being web pages, HTML, and clients around the world on the internet request data from web pages, and on the web server on the internet the web page goes off and finds its SQL database. It sends select queries to that, or insert queries to that, or update or delete, and the database returns SQL data back to the web page, which then returns it back to the client as HTML, so you can view it on your web page. And that's why the SQL doesn't look pretty in the command line client, but the web pages make it look much more user-friendly. Each user has permissions and roles in a modern database management system, so you can set up, the administrator has full insert, delete, update permissions, but users may just have select permissions, so they can't delete any of the data, they can just read it, or they might have insert but not edit. So you can set different permissions in SQL to different users. You don't normally set permissions to users, you set them to roles, and you add users to roles. That's a more efficient way of going. Databases allow easy data transfer using forms, so it's easy to input data using a data entry form, using text boxes to type stuff into. That just makes it user friendly, and the SQL runs once you've used the data entry form. You run a query to search using select statements behind the scenes to do the searches, so filtering a website to change which projects you're looking at, modifies the where clauses so you can see things coming back. And databases allow reports to be run. That's another way of outputting the data in a way which is very user friendly, and reports can graph the data and show totals and summaries of the data, which is another way of going. So those are all the features of database management system.